In this session, we are going to be discussing about recursive functions. So what is a recursive function? A function which calls itself is called as a recursive function. Fine. When we talk about recursive function, what is that we need to be looking into, or what are the aspects that we need to take care of? So as I stated, first of all, it should call itself. Okay. But again, there should be a base case. When we write a recursive function, the algorithm, that is the recursive algorithm, must have a base case, because base case is the one during which it would not call itself. So unless you have a base case, the function is going to be recursively calling itself and would not be coming out of the loop. And it is not just that. So when we are having the recursive algorithm, we need to keep on changing the state of the value, or rather when I say I'm going to have the base case decided based on the value of one particular parameter, so that parametric value should change for every time we are calling the function. Unless that is done, the recursiveness would not come to reach the base case, even if you write the base case. Now, if we look at the syntax of the recursive function, it would be more or less similar to that of the normal function, except for that we would have at least one statement where we are going to call the function itself. Say return type, function name, arguments being passed, the local declarations, all that is going to be the same, and we would have one body of the function. In that body, we need to have at least these two statements to be present. So one is the base case and the second one is calling this function. Okay, these two statements should mandatorily be present within the body. I mean, it could be the statement followed by so many other statements, and then you have this, and you might have a couple of other statements, or it could be the other way. You can have this as the first statement, then you might have the base case, depending upon your problem for which you are writing the solution. You might be adding statements either before the base case or after the base case, or the base case could be before the calling of the same function, or it could be after that. Okay, let us consider a very simple example of finding the factorial. So we can do that with looping statement. It is also possible for us to write a recursive version of it. But in general, we normally say when we are able to have a recursive version, it is better to go for recursive version than to go in for what to say, recursive in the sense the looping statements, rather than going in for recursive function. Okay, recursive statement can be used instead of recursive function. Why? Because the cost involved in recursively calling the functions is more. How? We are going to be storing the current version's data onto the stack and then move to the next version. So since we are going to be doing all that, some amount of memory is required, some amount of time is needed for storing them and retrieving them and all that. Okay. So that way, wherever possible, you need to use recursive statement and not recursive function. So if there might be scenarios where it is not possible for you to do the process by using recursive statements. So in such case, you need to go in for using the recursive function. So in our function for factorial, anyway, there is a base case, which means that if my number value is equal to 0, I need to be returning a 1. Okay. So otherwise, I need to return factorial of num minus 1 into the number. So in this case, every time we are going to decrement the number by 1 and keep on calling the factorial, and the current version's number will get multiplied. So once we move to the level of factorial being invoked with a value of 0, then it won't be having any recursion. It would return the value 1, and so in the reverse order the computation will happen and we would be getting the final output for whatever number has been given. Now let us see how exactly this is happening with the help of another example. Now we are having a sample program to sum first n natural numbers. Okay, so we are going to be reading the number and then we are invoking the sum function. So what is the body of the sum function? If n is not equal to 0, then it will return n plus sum of n minus 1. Otherwise, it is going to return n, which means if n is 0, it would return 0. Otherwise, it would return n plus sum of n minus 1. So with that said, let us move on to looking at how this works. Okay, so now what happens? We are going to give a value as 3. Say for example, to find the factorial of 3, we are going to say sum is equal to, result is equal to sum of 3. Now the function will get invoked with n value as 3. With that as 3, when it comes in, it would have to return 3 plus sum of 2. Okay, because n minus 1 is 2. It has to invoke sum of 2. So once it invokes sum of 2, then it goes into the sum function again, but this time the n value will be 2. So now again the sum function, it is going to check whether n is equal to 0. It is not equal to 0, so it is going to return 2 plus sum of 1. So now again with 1, sum is being invoked. So now it is checking if n is not equal to 0. Yes, it is not equal to 0. So return 1 plus 0. 0 in the sense sum is invoked with a value of 0. Now we are again going into the function sum. Okay. So now it is checking whether n is not equal to 0. No, it is equal to 0. So it goes to the else part. So it will return the value 1. So this value 1 will get returned here and 1 plus 0. Now we will get the result to return. Now it would return to the previous version. Okay. So this 0 will get returned here. So, I mean, 1 plus 0 will get returned here. So we would get a value of 1 there. Okay. So when we have this 1, then we would get this sum as 2 plus 1, 3. So 3 will get returned here. Okay. Now 3 plus 3, you would get the answer as 6. So it would be assigned to result. So this is how a recursive function would work. So I have taken a very simple example so that you would be able to understand how it works. So to know a little bit more about this, we will have the discussion in the class. Thank you.